Okay, guys, so for 3.5, I really recommend you go through, you read the beginning of the section. Some of the most important part, let me show you right now. Some of the most important parts are these, where they talk about asymptotes on page 365. And they talk about determining asymptotes. Then on the next page, they have a sort of a checklist to go through on how to graph these things. Okay, so I want to show you where everything sort of comes from. So the important part, the difference between a polynomial and a rational function is a polynomial function we know is smooth and continuous, no stops, no breaks. With a rational function, well, rational means fraction, it's a fraction. This is where you'll see things like horizontal asymptotes, vertical asymptotes, things like that's occurring. So I want to go through a graph right now and see how we can go ahead and construct it by hand, where everything's coming from. So suppose I have something like this. F of x is equal to 2x over x plus 3 times x minus 2. Okay? Now with these rational functions, like we said, we do have asymptotes. Okay? So the first thing I want to talk about are vertical asymptotes. Okay? And vertical asymptotes, what I want you to think about is division by 0. Okay? I want to know what values of x would cause division by 0. Okay? So if you look at this, I think it's easy to see that there's two things that x cannot be. X cannot be equal to -3 or 2. That's from these two factors down here. Okay? Well, that's fine and dandy. What does that mean about our graph, though? That's the question. Well, on our graph, I'm going to start drawing a graph for this. The way we signify that, okay, 3, 4, 1, 2, 1, 2, 3, 4. The way we're going to signify that is right here at -3, when x is equal to -3. Notice I'm drawing in this vertical sort of dashed line, x equal to -3. That says, hey, we can never cross this line because x can never be -3. We're going to do the same thing for x equal to 2. X equal to 2. Okay? So those are those vertical asymptotes. Okay? So there's our graph. I want to go back to our equation here. Okay? So we said x cannot be equal to -3 and 2. What that tells us is that our vertical asymptotes are x equal to -3 and x equal to 2. Those are those dashed lines. Dashed vertical lines. Okay? We can never cross those. Okay? Never cross. Okay? So that's fine. We also have something called a horizontal asymptote. Okay? Now, this horizontal asymptote, the key thing I want you to think about in this case is what happens for large positive or negative x values. Okay? That's what I want you to think of. Okay? So, when I look at this, let's suppose I go up and I were to multiply this out. This is 2x over x squared plus x minus 6. Okay? Now, here's what I want you to notice. If I asked you what happens when x is a very large number, let's say 1 million, which one's going to get bigger faster, the numerator or the denominator? You'd be correct if you said the denominator, because here you have 2 times 1 million. Down here, I don't really care what this is, but this is 1 million squared. The bottom is getting bigger much faster than the top, okay? If the bottom's getting bigger much faster than the top, what is this getting closer to? Well, if the denominator is much bigger than the numerator, it's getting closer to 0, okay? So in this case, my horizontal asymptote is a horizontal dashed line, y equal to 0. And likewise, you could ask yourself what f of -1 million is. Okay. Once again, think about it. If I put in f of negative, we'll just use 100. Okay. This is going to be -200 over -100 squared is 10,000 plus, I don't really care. This is very close to 0. So that's also going to 0. So you can plug in values just to kind of see what's happening. So the horizontal asymptote is telling us what's happening in the long run. What I mean is, on here, what is happening as we go out really far to the left and really far to the right? Well, our graph is getting closer and closer to y equal to 0, okay? Now, one thing that's different between this and the vertical asymptote that I want to say about the horizontal asymptote is that we can cross this. Can cross. Not always, but sometimes we do. Okay? How do we check if it crosses? Okay? How do we check if it crosses? Well, let's just see if the function value is ever equal to that y value, that 0. That would tell us. That would actually be the same as asking us what the x-intercepts are. Okay? So I'll take 2x over x squared plus x minus 6, x squared plus x minus 6, and I'm going to set it equal to 0. Okay? This would mean that then if I start solving this, I multiply both sides by the denominator. 2x equals 0. Oh, wait, x equals 0. So since I was able to find an x value such that f of x is equal to 0, this works out just fine. Okay? If we go back to our graph, that means we're going to cross right here at 0, 0. That's also an x-intercept. Okay? Now that's fine. Okay? If we're trying to figure this out and we got nonsense like 2 equals -3 or we didn't get an x value, then it won't cross. So once we have our asymptotes, okay, then we want to know a few things. We want to know, for one, what is our y-intercept? Well, what's true at the y-intercept? That's when x is equal to 0. So guess what we do? We figure out what f of 0 is. Well, that's just going to be 2 times 0 over 0 plus 3 times 0 minus 2. I'm using that first form here, just plugging in zeros. And that's just going to be 0. So I know I have an y-intercept at 0, 0. I'm not so surprised because look at my graph. I already picked that up when I was checking if we cross the horizontal asymptote. So now we're going ahead. We're looking at this. That's fine. We probably want to know what x-intercepts are. And just like before, now we're going to let y be equal to 0 in this case. But once again, I also expect 0, 0 to show up here. The shortcut to this is you just take the top and set it equal to 0. Because then the bottom, just like we did before, when multiplied by 0, will just be 0. So it's a little bit of a shortcut, but we get x equals 0. That's nothing new. Once again, we pick up that 0, 0 spot. It's almost like we're double checking our work. Okay. So from there, the question becomes, okay, well, what can we do with this? What is it looking like? Okay. Well, let's go to our graph. Okay. So here's our graph. Once again, our function is f of x equals 2x over x plus 3 times x minus 2. Right there. Okay. So we know we're crossing here. What's happening here and here, though? Okay, well, we can just check it. What is f of 1? That's going to be 2 times 1 over 1 plus 3 is 4. 1 minus 2 is -1. I'm seeing that's going to be 2 over -4 or -1/2. So I know right here I have 1 comma, oh, sorry, I actually have right here, 1 comma -1/2. Since I know this is crossing and its multiplicity is 1, I have to go through it, okay? Now, as I go down here, notice I can't cross the vertical asymptotes. We talked about that. So the only place this thing has to go is straight down, okay? Once we get up here, this is multiplicity 1 from the x-intercept, so we know it's a cross. As it goes this way, the only way it can go is up here because I know it's not going to cross over here. All right, so that's fine. Question is, what happens on the other sides? Well, I'll tell you, so you can remember this if you want, but you can always test points. This is multiplicity 1. This vertical asymptote right here, that came from down here, which is raised to the first power. And this is also multiplicity 1. So just like with the x-intercepts wheel, we can tell if it bounces or crosses depending on the multiplicity, we can also tell what's going to happen at the vertical asymptotes depending on the multiplicity. So these are both multiplicity 1. When multiplicity is 1, when we end low, we go high. When we end high, we go low. It always flip-flops on us, okay? Now, if you don't remember that, that's fine. You can just ask yourself, well, is it going to be positive or negative here? I know I'm not going to cross again. I would have picked that up earlier. So I'm going to just ask myself, well, what is f of 3, for example? Okay. Well, f of 3 is 2 times 3 over 6 times 1. I just know that that's going to be something positive. So at 3, x equal to 3, I know I'm somewhere up here. So I know it has to come here. I know it doesn't cross again, so it just tends to this value. Remember we said the horizontal asymptote tends to that value over the long run. And likewise over here, I could test something like -4. So let's try that real fast. F of -4, we get -8 over -1 times -6. I got 3 negatives. I know that's going to be something negative at x equal to -4. So I go down low, I'm down here. This is negative. I know it has to go like this. So this is what that graph looks like. This f of x equals 2x over x plus 3 times x minus 2. Okay. Like I said, an important thing to read over about these asymptotes is on page, I believe it's 365. Okay. It goes through the different types. It talks about the vertical asymptotes, no division by 0. The horizontal asymptotes, there's a few different cases. I'm going to do a few more problems like that. But you really need to be reading the book for this section. And then this goes through sort of a checklist on everything to check. And that's kind of what I went through just now. Okay. So there's your first example for 3.5.